Thank you all for coming. We'll be talking here about an operating system we started developing like 5 years, 6 years ago, more or less. It was actually inspired by another operating system called BOS. You probably heard of it. I know some of you did because you actually worked on it. And we will try to show you, we will try to explain the whys, the hows, and who's of this operating system, and especially why we do believe that it's a good idea to continue developing it, and in the same spirit that Being Incorporated, who created BOS originally, started working, did work on it. So my name is Bruno. I'm actually the OpenBFS team lead, which is the file system that we use. All its design was actually created by Being Incorporated. We just stole it, more or less, and re-implemented it from scratch. We also will have here Michael Phipps, which is our project leader. He actually created all this. We have Axel Dorfler, who is our main kernel engineer, and he's responsible for most bugs that we have, but also he's responsible for most of the stuff we have working. And we have also our marketing guy here. He won't be talking, but Jorge Mari have been helping us to get this stuff done and everything else. So we have the presence here of someone without whom I think we would not be here, because it was his vision who started all this. With BOS and everything. So I would like to invite Jean-Louis Gasset to say some words for us. So please.
Thank you, Bruno. Good afternoon. It's quite, I should say, quite moving and amusing at the same time. I see some faces of people I've worked with at B and others as well, and to be inside the Googleplex to have this talk about the BOS is BFS, the Haiku. My English not so good, better getting. So to have this discussion of Haiku is quite interesting. I went before coming here. I went, of course, to the website, to the new website, and the screenshots, where are quite impressive. And then I saw some screenshots on the screen here. So it brings all sorts of memories. From my perspective on this is not so much about nostalgia. The joke about nostalgia, it's not what it used to be. I'm sorry, I couldn't help. It's about pushing the technology into all sorts of directions, because if it were left to a certain company, we would still have an operating system with 3 letters and a graphic shell on top of that operating system. Because they would be revising it. There would be no competitions. There would be no needling and no agitation of ideas. I don't want to use the D word because it's been overused in the state of California. So I try not to do that. But you want a technology ecosystem that has all sorts of alive components, and the combination of those components sometimes yields unexpected results. And look at the company that hosts us today. I remember when these guys, the founders, went to see the venture guys. I'm now one. I went over to the dark side. I'm a vulture capitalist. The people from the B days recall that I had 2 pigs on my desk. Right? In '91, I hated the VC so much that I was in France on vacation. I went by an antique store, and I had a start, so I bought these 2 ceramic pigs, turn-of-the-century costumes, one as a butcher, the other one as a cattle merchant, and I called them Victor and Charles. Very subtle. So when the entrepreneurs now give me guff about about the venture guys. I take them to visit Victor and Charles. But the interesting thing is that this company came to see the venture guys, and the venture guys said, we have search engines already. We have Alta Vista, we have Yahoo. Buzz off. Actually, they use another word before off. Same number of letters. And we know, of course, with perfect hindsight, we know what happened. So the maintaining or developing strange components in the technology scene is precious. Sometimes that doesn't apply to Haiku, but I used to say that there's no good culture without bad taste. This is not about Haiku, but there's no culture without people. I'm not going to use the pushing the E word either, because that's been abused. But there's no good culture without people trying something new, trying something different. So it's quite precious to do this. So I feel very touched to be invited here. I see Steve Horowitz, and we have great memories of being on stage together. Steve giving the demonstration that got us a standing ovation at Agenda in '95, where we thought we were dying. A few weeks before, if it hadn't been for Leah Lorenzano, who was the producer of Agenda, the company would be dead. She pushed me and pushed me and pushed me to come and give a demo to Agenda, and that gave the engineers at B a push that they thought I was crazy. And please, they thought I was crazy. This was impossible, and everybody rushed and finally delivered. It's a classic in our business. You have an insane deadline, and as a result, good things happen. So thanks for having me today. Thanks for the Haiku team first for choosing such a nice name for the effort. I think it's quite poetic, if I can use the word. And on to the next. Who's the next speaker? Okay, Michael. So thank you very much.
I just wanted to remind you guys that this presentation will actually be sent to Google Video and everything, so no confidential talk here to avoid any problems. And actually, the original name we thought about was Walter, but no one liked that, so we got with Haiku, so just so you know. So I would like to call them Michael Phipps, our project leader, to talk now.
And by we meant Bruno. No one else liked the name. I promised no bad puns, so you've been spared that at least. So Haiku, what is it all about? It's a new OS, and interestingly enough, based on new OS, written by a former B engineer named Travis. Our first release will be binary backward compatible with BOS R5. And a lot of people have looked at that and sort of tilted their head and said, why? I'm sure there can't possibly be any software still worth having. In truth, there are a few reasons for binary backward compatibility. One is to keep us honest, make sure we don't accidentally break something or forget something. Another possible good reason is that there are a few applications left that we don't have source for. We have a custom kernel designed for responsiveness. I just came from a Linux conference, and I love Linux. I use it all the time, but their kernel is designed for a number of situations. Our kernel is optimized for responsiveness. With something like Linux, when you want to make a Linux desktop, you pile X Windows on top, you pile GNOME or KDE on top, or Enlightenment, or a number of different environments. We think that by creating a unified and cohesive interface, we can go one step better and bring a little bit better user interface to the user. We go for the best defaults, not maximum configurability. Any cases where we can choose what most people will like and either avoid the option or have an option only in an obscure place is a little bit better than maybe presenting a user with 2,000 checkboxes. And we're open source, MIT licensed. We believe that that'll give us the best opportunity for expanding the Haiku ecosystem. How does Haiku compare to BOS R5? We implement the entire R5 public layout, but we have some extensions, some things like UI layout, which I know was coming in BOS R6, but we sort of went our own way there because we didn't have access. And we have a disk device API that makes it a little bit easier to do things like partitioning. We have drivers for current hardware, something, again, that I'm sure B would have had the time come around. We've added complete USB 1.1 and 2.0 support. We have SATA. We have basically all of the current video drivers covered. And AC97 audio. Another item that B, I'm sure, was, and I know for a fact, was working on was networking in the kernel. And we knew that that was the right way to go, so we were able to implement that. Another item that I'm sure Dominic was really interested in was the file caching integrated with virtual memory. It scales a little better, so if you have a lot of memory, you can get some performance benefits, and it also means that applications will not have to load twice in some circumstances. We have vector-based icons, and this is something that a lot of people are implementing now because with ever-growing monitors, it's nice to be able to have something a little bit bigger than 32 by 32. But it's also a little bit tricky because a lot of the vector formats out there, like SVG, are too big to fit in the small space that you have for attributes for quick reference. So what we've done is we've designed our own vector format that actually compresses the icons more than something like SVG. I think we're going to cover that a little bit later on. We have support for more modern hardware. Their BOS R5 had a 1 gigabyte limit. And that's for all map devices, so even if you had a little less than a gigabyte, you could get stuck. We've removed that limitation, and in fact, the laptop we'll be demoing on has a full gig of memory. And we've improved POSIX compatibility. One of the big sticking points for BOS R5 was that it didn't have things like mmap, which made porting a lot of Linux tools and a lot of Unix tools a little bit difficult. And we've implemented that as a sort of a benefit of the integration with the file caching. Why Haiku? A lot of the same reasons for R5. Simplicity is the key. Multi-core and multi-processor is the future. You know, the old slogan, one processor is just not enough for anyone. Well, we believe so too. And in fact, the hardware market has very much proved that out. So we've focused on keeping the threaded technologies, what was it used to be, pervasive multi-threading. We focused on keeping that. We have a desktop focus. We don't want to be a server or a wristwatch or Blue Jean or anything else. We're on the desktop and nowhere else. That gives us the ability to make some trade-offs, and it very clearly allows us to set our priorities. We have a small footprint and fast boot. We actually have improved, I think, just a little bit on R5's boot time, and we're at about 60 meg for a full distribution, which is right around where R5 was. This integrated approach brings a lot of benefits. I alluded to it earlier. The one operating environment allows maximum platform features. There are a lot of features, for example, that the Linux kernel brings along that GNOME and KDE can't easily take advantage of because FreeBSD doesn't offer them. By having one integrated environment, the kernel can make decisions that we know are appropriate for the UI, and the UI can take every advantage of the kernel. And we have fewer cases to test and debug. If you look, I feel sorry for the poor KDE and GNOME guys because they have to test and debug on FreeBSD, OpenBSD, NetBSD, multiple Linux kernels, and sometimes, on occasion, Windows. History and progress. We started the day that B announced the end of BOS on August 18th, 2001. We have dozens of contributors from all over the world. You'll hear people, Bruno is from Brazil. We have a presenter here from Germany. We have developers in France, Italy, Australia, and more. And we're nearly feature complete. There's still a few little things that we want to implement, but we're real close. But we still have many, many, many bugs to find and fix, and you folks are, of course, all welcome. We also have over 7 million lines of code. So there's not a lot of lack of bedtime reading. Philosophy. Proprietary OSs force you to follow the manufacturer's direction. It's actually sort of fun to watch Vista applications because a lot of people that use their own toolkits, their own UI controls, they look odd when Microsoft releases a new OS. Open source projects encourage forks and alternative projects, and there's been lots and lots of forks of many different projects. Haiku encourages you to guide from within. So rather than saying taking the Haiku code, forking it, and going and doing something else, we encourage people to come into the project and work with us and add more rather than having forks. We have one desktop, one UI, one media kit. Everything is tied together for maximum integration. Do the right thing. Human interface design is very important to us. We have frequent heated debates, let's say, on what the interfaces should look like. We want to be easy enough that your mom can use it, but powerful enough that you want to. Our one common look makes documentation, support, and QA easier. You don't have to test under 10 different themes, different window managers, whatever. We just, with one way of doing things, everything should just work. And we choose common cases as the defaults. So for example, if you have a network card, we assume that you want to use it, and we probe for it. We hide as much as possible the inner workings of the OS. Sometimes there are things that have to be exposed, but where possible, the user doesn't really want to know. They just want to boot up and have it work. So we figure out where possible instead of asking. We assume the normal but allow the unusual. Technical stuff. The small boot footprint and fast boot, I alluded to this a little. We're around 60 meg uncompressed. We're small enough to fit on a flash drive. There's all sorts of neat embedded possibilities that allows. We're working on PXE boot. And applications start quickly under Haiku. It's very interesting to watch other operating systems, and it takes 5, 6, 7 seconds for an application to start sometimes, whereas ours start much more quickly. And with a smaller footprint and faster boot, there's less need to leave the computer on. We boot, depending on the hardware, in 7 to 10 seconds, which, for example, I've seen people put a computer in their kitchen to use recipes, and it sits there and gathers dust because by the time they turn the computer on, boot it up, get to the UI, and pick a recipe, the food's already burned. C++ is our native language. We have a little bit of C++ in the kernel and C++ everywhere else. We believe it's the best option for writing an operating system today. It's the best balance between performance and readability. And there's lots of code available for virtually any tasks. If I need some C++ code, I Google C++ and whatever, and there it is. The object-oriented API allows faster development, and low-level C++ is possible if you're careful. Our entire file system is written in C++. C++ is also low overhead, and you don't need a VM, so it's a little bit better choice than something like Python, which is a wonderful language which I adore. OpenBFS is fully buzzword-enabled. 64-bit journaled, has attributes, indexes, live updates, it's multi-threaded, and it's object-oriented, which sounds very familiar to, I'm sure, a bunch of you. It's built for large files like movies and MP3s. We're sort of coming into our glory there. You know, B was looking a little bit ahead, and now people are starting to really see the desire to have movies and MP3s on their desktop a little bit more than they did in 1997. The database database-like queries that BFS offers allows us to make Gmail-style labels work on the desktop. So you can say things like, show me all my jazz albums, show me all of the songs recorded in 1986. It's a way of working that Google is actually bringing to most users, and it's something that we'll enable on the desktop in an interesting way. And files are MIME-typed, no TLAs or three-letter acronyms needed. Kits. A kit is a complete API, like the networking kit, the interface kit, the media kit, the print kit. It's a lot more cohesive than than what the Linux folks do in a lot of cases with things like ImageMagick or libjpeg. Those aren't really quite fully comprehensive, and when you have to use two together, sometimes it's a little tricky. These rich APIs are built into the OS. You know, coming from a Linux conference, this is one of the things that it really hit a point for the Linux folks, that fewer libraries mean fewer dependencies. Everybody asked me how we do package management. I said, we really don't do package management because you can just take an executable, drop it on the desktop, and it works. It's easier to build apps with this complete rich API. You know beyond a doubt what will be on any given Haiku R1 machine. And it makes it more productive to code. You don't have to go and look and say, is there a library around that does this? It's just available on the desktop with a complete set of documentation. For example, building an application that reads bitmaps. It leverages our translator kit instead of coding again and linking with libjpeg, libgif, etc. Replicants. A replicant is a serialized instance of a Haiku application, and they're one of my favorite features. It's one of the things that I think really sets Haiku apart. They've been around since 1998 or so, probably longer internally, but I saw them first in 1998. And they used the native serial and serialization and messaging technology. Other platforms call these gadgets or widgets, but ours are embeddable inside applications. And there's a good application out there called Be Happy, which uses the net positive web browser that Be developed to view documentation, and they just instantiate a web browser inside another application. Files are power. Contacts and emails, the People application, and Bmail in particular, are applications that are designed to use the files saved with attributes. The standard format means never converting. I've used probably 5 or 6 different email applications in my time with BOS and Haiku, and I've never once had to import or export. It just works. Any application, including trackers, our desktop, can view these files, so you don't need necessarily a special application to change somebody's name. And attributes give database-like functionality. I see this over and over again. I'll search for files from Axel within the last week about Google. More file types are easily definable and extensible. I had someone ask me how they could build an application to store all their jazz albums. And I said, just make a new file type and set up some attributes. This person doesn't code at all, and he was able to do that without writing a single line of code. And you can easily build mini apps. I referred to People and Bmail. There's a really sort of mini apps. They don't manage your email. All they do is display an email or display a single person. And you use the desktop windows to manage people or email messages. Add-ons are an enhanced library loading interface. They make it easy to extend applications and the OS. It allows people to build up applications instead of building everything in. Photoshop does this, for example, with the Photoshop plugins, but BOS and Haiku make it a lot easier to do that with every application, and there were a wide variety of applications that used add-ons. Because the original author can't think of everything, and it means that apps don't have to be monolithic. Scripting, another favorite topic. All applications are fully scriptable. The OS standard scripting mechanism can be implemented in any language. I've seen it in Python. I've seen it in the shell with actually Marco's Hey. And it allows people to do things that are very difficult in another operating system. Adding more scripting nouns to your application is easy, so you can say, hey tracker, quit. Hey Bmail, print. And there are a number of nouns that are system standard, and it's easy to add more. It allows for inter-application interaction in new and different ways, but still with a standard mechanism. And I think here's the point where I hand over to Axel. Thank you.
I wanted to talk a bit about the virtual memory subsystem and the file system cache. Oh. Okay, better now? I want to talk about the virtual memory subsystem and the file system cache implementation. It probably won't take that long, though. Don't worry. The basic design is very BSD-like in that we have memory caches that stack up together to build the memory that backs up an area or region or whatever you want to call it. Every piece of memory is backed up by a virtual memory cache object that, and those might be stacked up to deliver every page you wanted to look for. Anyway, it also has a reverse page mappings and a global page scanner. Unlike BOS, the file system cache is fully integrated with the virtual memory, which means that every file just have a pointer to a virtual memory cache object. The file system interface is one point where we didn't duplicate the R5 API, but improved it a bit, and so that you have to actually port the file systems over to Haiku if you wanted to use them. It has a transaction API, and it comes not only with a block cache, but also with a file cache. The transaction API has actually support for sub-transactions, which means you can stack together several transactions and commit them at once. So you can also, unlike BOS, which has a similar thing, it also joins several transactions together, but therefore it cannot undo them. It can just not write them out or write them out. Due to the sub-transactions, we can also undo single transactions, which simplifies the file system implementation a lot, actually. BFS, for example, Bruno will talk later about it, now uses both caches, the block cache for its metadata and the file cache for everything else. But actually, the file system is free to choose whatever cache implementation it wants to. It's fully transparent. The virtual memory subsystem will just call a file system hook, and it will do the rest. Another feature of our file cache is that it allows for add-ons, which means it has hooks for every file cache operation. Whenever you open a file or read from a file, a hook gets called if you want to. Those add-ons are stackable. You can, for example, we have a logging add-on which just logs everything you do, and it still allows to have an additional add-on that actually do something useful. Right now we have a launch speed-up module. Both modules are very basic, actually, which just sees what files are opened when you launch an application and pre-caches them. As I said, it's very basic right now. When you boot Haiku, for example, it will actually load about twice as much data as a usual boot would do, but it's still like a few seconds faster. Because it's so basic, it's not yet enabled by default, though. And there's an API that allows to switch those caches, those modules at runtime. Another caching add-on I implemented is the rule-based add-on. It actually works hand-in-hand with the logging add-on. And it currently needs another system to actually evaluate and analyze the log output. There's an inductive logic system which has a set of rules, or creates a set of rules out of the logging data, and the rule-based add-on parses those and improves file system speed. For example, when you work on a project and you run your integrated development environment, it will maybe automatically cache GCC for you or the files you're currently working on. Well, that was actually all of what I wanted to talk about, and I give over to Bruno.
Okay, sorry. So I'll talk a bit about our file system. As I mentioned in the start of the presentation, this was actually completely designed by the big guys. And we actually used Dominic's book. The author of the file system actually printed a book about it. So we used that as a base, and we were able to recreate it. But we changed some stuff, and we actually added more features as long as we could without breaking on-disk structures compatibility. So the first thing we did is that we decided to actually write the file system in C++. Some kernel engineers would think we are completely crazy or something like that, because C++ in the kernel is like something that's basically forbidden. We decided to go that way because first, it's a lot easier to maintain. Second, you can actually make the code a lot more clean, so it's easier to understand and it's easier to implement the code piece by piece. So for instance, the first thing we added was actually read support, then we added write support, then we added query support, then transaction support, and it was very clear how we would add all that since from the start of the project. So that helped development a lot. We also decided to actually implement some stuff that we considered that was missing from BOS. So we also implemented support for non-indexed attributes. In BOS, you couldn't really search for non-indexed attributes, so we added that. But all in all, it's basically the same file system. So for the ones of the people who does not know, what exactly is OpenBFS? So as Michael mentioned, OpenBFS is a 64-bit, multi-threaded, object-oriented, database-like file system. I think the most unique feature in OpenBFS is exactly the fact that it is a database-like file system. What exactly does that mean? When you have a file in your file system, you usually have standard attributes, and those will be the file name and file size and permissions and ownership and stuff like that. OpenBFS actually takes that a step further by actually allowing you to attach any arbitrary attributes to your file. So you can, for instance, in an audio file, you can have an attribute that says who is the artist that composed that file, what is the album, what's the year, and other stuff like that. This feature alone is not really exciting, but then the file system also has an internal index implementation, so you can actually index those extended attributes. So you are actually able to make search, really fast searches actually, based on those attributes. So, for example, I have a huge collection of MP3s at home. I still run BOS, by the way, and I can do stuff like show me all MP3 files that I gave a rating of 8 that are from the late 80s and that has rock on its genre someplace. So it will return me like 200 files, and it's like almost instantaneous. It takes like 1 second, 2 seconds to actually do that. And you can extend that to any file type you want, because you can actually create your own file types, and you can do those kind of search without having to actually code anything. So it's pretty easy to do that. So as I mentioned, we actually added support for non-indexed attributes, which in BOS you could not really search for an attribute that was not indexed. It would simply return nothing and would not say anything about that to you. So we actually cheat, because when someone does a search for any attribute that is not indexed, we use an attribute that we always know that we know that always has all files. For example, last modified date. and then we iterate over the results, which are all files on your hard drive, and we check for the attribute that is not indexed. It's a lot slower than standard queries, but it's a lot faster than actually trying to search your entire disk for that, because you just load the index and you process it. We also did several optimizations in OpenBFS that actually make it a bit more fast than the BOS version to actually retrieve the data. We actually implemented several optimizations for partial matches. We did several. I won't really go much in too much detail here, but we basically can use the user pattern to actually give a smaller subset of files for it to search in the index, so it can actually return results a lot faster, especially if you're doing search for like the name index that has all the files or possible files indexed. Sorry. Another thing that we did is that we came up with our own implementation of B+3 for the files. It's also for the on-disk structure. It's also C++, and that also helped a lot too during development, because we really found several bugs that we could easily fix them with that. And this is one of the this serves to show the direction we are trying to actually go, which is exactly improving upon BOS as soon as we have our first version released. Another thing, actually I moved the slides here, but I don't have a slide for that, so anyway. Another thing that we actually implemented, and is quite interesting, is our icon format. They are vector icons, and probably most XB engineers here know why it's not a good idea to actually use vector icons in the case of BFS. But especially considering that when you're using like an SVG icon, you probably have icons which are bigger than 5K, that's compressed size. So we actually came up with our own icon format, which is called HVI. It's actually a vector format, but it has several restrictions that were designed for icons. So in the sense that if you are going to use it as a general vector format for files, it will suck big time. But when you use that for icons specifically, it's very good. We did some tests, and because we also created a program that would be able to actually create those files. And we did some tests. We had SVG files with 8 to 10K compressed. And the same icon, when made with our vector format, is only 800 bytes. So for the more technical inclined, especially the big people here, 800 bytes still fit in the small data section. So we don't pay the penalty of actually having to fetch the icon. How this works like this. We have the file inode, and after putting all standard attributes there, file information, you still have some space left on the inode. So when you stat a file, you have to actually read the inode. So we got that free space. Actually, it was an idea that came from B itself. And we use that space. We call that space the small data section, and we can actually write some attributes there. The icon itself is an attribute. So as long as the icon fits that area, when you fetch the inode for the file, you actually get the icon too. So we managed to have vector icons with the same performance that B had with bitmap icons. Of course, we still pay a penalty, but it's very small, because we actually have to render the icons. And then rendering the icons is also pretty smart. We do single pass rendering, so the borders look actually perfect. SVG tend to do multi-pass rendering, and when compared to the quality of our icons, it sucks. It really sucks. And as it is one-pass rendering, it's also a lot faster. So this is something that we created, and we are kind of proud of. Actually, it was a developer from Germany called Stefan Asmus, and he did a great job with that. Well, after we finish our first version, which is what we intend to do real soon now, you guys probably remember that too, and we will basically have R5 with some minor new features and some minor new optimizations here and there, but we still have a lot of work to do. So what we intend to do from now on, after we have R1 out. So basically, we will stay with our focus, but there are several things that we want to actually make better. Right now, we have, just as an example, our syscall mechanism is like 10 times slower than Linux. We are completely aware of that. We know how to fix that. We just decided not to do it right now. So we would just get it out of the door, and then we actually work on improving that. We have several ideas on how to do that. Another thing that we will do, and that's really, really required, we will create another BFS, Open BFS, which will be version 2. We will completely break down disk structures because, well, Dominic had 6 months to do Open the original BFS. So the fact is that it does not scale well. Especially with the small files, our file system sucks because when you're actually deleting files, you have to also handle all the metadata, extended attributes, indexes, and stuff like that. And we are actually considering ideas for improvement upon that and to actually get it faster. We will be faster than R5 in this respect because we have, as Axel mentioned, we have an integrated file cache API and the VM, so we can actually use all available memory as cache, and that will give a good speed boost for us. And we are really a small team of developers, although we should have around 40, I would guess, developers that contribute one way or another. We're really writing code. There should be around 10 developers. And we didn't do a bad job, considering that we have 7 million lines of code that were written in 6 years by 10 developers. There is this site, I don't remember the name, that it tries to evaluate the amount of work that was put in a project and how much it would amount if someone was actually paying for that project to be designed. And they decided that our project is worth more or less $83 million US. So I want some of those. I don't know how, but I would try. I would ask the guy who generated this number and sell the project to them for like $1,000. Is that okay? Okay, perfect. Okay. So, well, I hope you guys enjoyed this presentation. Oops. We have here some contact information. So you can find our site, which is haiku-os.org. We have a channel on our IRC, which are always full of people with great ideas on how we should do everything, but that don't move one single finger to do anything. But that's the usual stuff with open source projects. We still have a mailing list. Actually, our project started being called Open BOS. But what we didn't want to get, we didn't avoid the possibility of getting sued eventually due to that, so we ended up changing the name. And but we do have this mailing list. It should change soon, but it's still called OpenBOS, and you can find it on freelist.org. So thank you all for coming. If you have any questions, feel free to ask them. And please do. Actually, we are here to answer that. Any questions? Oh yeah, of course. We would do that. We need his laptop, so there we go. That was a good question, actually. Oh.
I just want to point out that's the actual R5 bbounce binary running. I thought you might appreciate that.
Yeah. What do you want to see? KDL?
Do the right thing and start with what they will be seeing a lot.
Okay, our second best user interface looks like this. You might be familiar with it. The kernel debugger on screen, which is comes in very handy for laptops that don't have a serial debug output, like this one, for example. But other than that, it's not that useful for common tasks. Although someone actually wrote some kernel add-ons for playing games while you're bored and Haiku crashed. Anyway, is there anything particular you want to see? It runs currently at 600 megahertz. That's why it's a bit slow. And it's also not optimized at all at this point. Like Bruno said, the syscall mechanism is like 10 times as slow as Linux. And there are lots of other places where probably the same numbers apply, except sorting B outline lists, which is about 1,700 times as fast on Haiku. I don't know what some of you were doing there. Just wanted to mention it. Well, you see the vector icons here, where, for example, when it decides to come up, our iconomatic. That name should sound familiar as well. And they can, for example, see what kind of optimizations are done to actually achieve small file sizes. The usual size is about 200 or 300 bytes. I can add some curves here. And multiple shapes can reuse the same path. So I can have a second shape which reuses the same path. Oops, what did I do there? That's okay. And I can move them and turn them around like I want. I can have different styles for each one, like and gradients, of course. And if I afterwards change the path, or should be able to change the path, this application actually has quite a few bugs. Both on screen will change accordingly. And it also has a level of details. So if I don't want to see a certain object in a certain size, like text on a text icon, when it's smaller than a certain amount, I could use like 04, and in this preview I see it's gone at that size, but at others it's still there. There are other things like perspective on contour and stroke I can apply to existing shapes, so to save actual space. I don't have to duplicate a lot of paths to create an icon. But that's just one thing. Any other stuff you want to see?
What kind of app compatibility do you do?
It's have what?
Soundplay.
Yeah. Sound.
I can get this one. I can. Actually, we tried to have SoundPlay, but someone ended up using undocumented APIs on it, so we have an older version that works, but the most recent version doesn't. But an older one does. I don't know. You remember?
Not sure. Some add-on.
I think it was something to actually list all the add-ons that were installed and to figure out what they were. I think it was the name was indicated that it was
Something
that.
in the media kit.
Yeah, something in the media kit, actually. So it's your fault it's not running, okay?
4.7.3 is the last one that works. Just for a number. Yeah, it should be on here somewhere.
Or you can try to see the lamp or the media player.
There is one thing that I want to make clear. You see, when he was moving windows around you see the jittering on the screen and everything. That's because we are actually running a debugging version that does full locking of the application server when you do anything. So that's why when you move on one window, the other stop. But that doesn't usually happen. But if you were not using the debug version, it would crash. So it's better for you to see the jittering than the crash.
Another bug you see here, those nice little rectangles. Currently, I disabled outline fonts because they would just hang the server somehow, and it looks not that bad, actually. We've also net positive running, and the B version, R5 version of Firefox runs as well. Some games don't work for some reason, like Worms can't be played yet. Worms, I'm again.
Worms are again.
Yeah, exactly. Huh? Should
You should show a little bit of the track.
like? I
Bring open.
I could enlarge the icons, of course. It's quite slow, as you can see right now, but as I said, it's not optimized. I think all text on screen is actually rendered each time and not cached in any way. We have a media player, yes.
Well, it doesn't work like it do.
It does.
It's actually bitmap drawing, but we also have overlay working. It's just that the media player, the native media player, just doesn't support it yet. But if you use a VLC, for example, it would use the overlay as well. And another thing you can see here, the mouse cursor is blinking because we have soft cursor only right now. It's not that hard to change, but somehow we wanted to have a shadow on our mouse cursor, and it wasn't possible with the original App Server Graphics Accelerant API. Oh yeah, and of course, those one work as well. With the sole difference, if I close and reopen, it actually stores where they were. Well, anything else you want to see?
I think someone said query.
Query, yeah, okay, can do that. Whoops, no, that was the wrong one. I mount my media partition.
The alphabet, I'm still on.
It actually has an old icon, as you can see. Well, what could I look for? Maybe I'll search for a JPEG image with have DC in it. There should be some of them. This is, of course, a search that isn't optimized at all, as you might know, because the on-disk structure of BFS just doesn't allow for certain optimizations. But if I, obviously there are no. But if I, okay, I'll check, let's just change it. I look out for BFS. So there are some files at least. Yeah.
Okay, create one in the show and then erase it.
Okay, if you want me to, I can do that. So if I now create a file like BFS, and as soon as I create it, it of course shows up in the query, and as soon as I delete it, it should also be removed from the query window as well. Oh, and OpenTracker now also can has this little icon up here where you can grab the contents of the current window and just copy it here. This works with all of this stuff, so I can grab this folder and can copy it anywhere. I won't do that right now, though.
Because it will crash.
Yeah, it might crash. It's not good in it during a demo. Yeah.
But you repeat the question.
We do have Firefox, yes. I can start it up.
What kind of networking support do we have now? Networking support?
Not from here, but usually we would have. Yes. DHCP is implemented. TCP, most of. It works, but not very well at that point. Firefox is one of the few applications that actually take a long time to load.
On any platform.
That's true.
Do you have a PE on there? Programmers that are
A what?
PE?
No, I tried to compile it before, but somehow there's a kernel regression as soon as I compile anything. There comes a nice KDL on top of the screen. I won't show it right now. So there's Firefox. It just crashed, but usually it would work. Not today, of course. But since we don't have network connection from here at Google, I think it's not that much of a problem. Any other questions? Is what? BDB is BDB. We don't have BDB. We have ported JDB over, but we don't have an actual graphical front end for it. It looks like this. I just started again. It probably crashes again. We'll see about that.
That's what prompted my question.
Okay. Any other questions while it loads Firefox?
Like how much of this is stuff that you wrote for Haiku and how much of it is BOS binaries running on?
The only thing which are BOS executables you saw is bbounce and R5 net positive. Everything else, if not like SoundPlay, it's Haiku code. So the debugger came up. And it should be familiar to any Unix developer.
That's right, thank you.
I won't look into this right now. It might be Haiku regression, I don't know. But it shouldn't even crash when you do that, so it did right now. Any other questions?
What's the relationship with the Zeta? I hadn't heard of it until Vince was done talking, and it sounds like there's
The relationship to Zeta, actually there is not that much of a relationship. Zeta offered some code to us, and there were a few lines where we shared code, but it's not that much actually. It's hopeful. We hope that it will improve over time, or that we get more code. They promised some drivers that we could use from them, but right now not much has happened in that regard.
So does GCC run under Haiku now?
GCC runs under Haiku, but it crashes. And not just GCC, but Haiku for some reason. It tends to write its environment variables somewhere in the kernel, and it doesn't like that. I don't know yet why, but it used to work. Like for my master thesis, which actually was the file caching stuff, the rule-based one I talked about. At that point, about 2 years ago, it would compile OpenTracker completely. Not much more, but that it did. Any other questions? Obviously not. Well then, thanks a lot for your attention and coming here.